Okay, in this first video, we are going to develop Euler's formula. I'm actually going to insert a video that goes through some good uh, visualization of what we're doing. You will see the same table. Please fill the table out as they are filling it out in the video and make any side notes that you see added in, and we'll talk about this at the end.
How many faces, vertices, and edges does each prism contain? Do you notice any patterns in these quantities? To help us answer these questions, we will complete a table of the number of faces, vertices, and edges for each prism. Remember, a face is a single surface, a vertex is a corner point, and an edge is a line segment that connects two vertices. Based off the data found, we will now look for patterns and relationships amongst these prisms. Let's start by focusing on the triangular prism. A triangular prism has 5 faces, 6 vertices, and 9 edges. Next, a rectangular prism has 6 faces, 8 vertices, and 12 edges. A pentagonal prism has 7 faces, 10 vertices, and 15 edges. Finally, a hexagonal prism has 8 faces, 12 vertices, and 18 edges. Now look at the table. In order to find a pattern, focus on how the data changes from row to row and note any similarities. Specifically, notice that the number of faces increases by 1 from row to row, the number of vertices increases by 2 from row to row, and the number of edges increases by 3 from row to row. Therefore, we can conclude that for each additional face on the prism gains 2 vertices and 3 edges. When we compare the number of edges to the sums of the faces and vertices, we see another pattern. In each case, notice that the equations are balanced if we add 2 to the number of edges. Therefore, we can conclude that the sum of the faces and vertices is always 2 more than the number of edges.
All right, so here is kind of the sentence you want to make sure you have added in. The sum of the faces and vertices is always 2 more than the number of edges. So that brings us to Euler's formula, which says, exactly what you just wrote in. The sum of the number of faces f and vertices v of a polyhedron is 2 more than the number of its edges. So here you can see a little formula. The number of faces plus the number of vertices is equal to the number of edges plus 2. And then here's just an example, kind of going through the math of that.